express first example number 1. Write a vector u bar. Write the vector u bar is equal to 1 minus 2 5 as a linear combination of the vectors v1 bar is equal to 1 1 1, v2 bar is equal to 1 2 3, and v3 bar is equal to 2 minus 1 1. So here we want to express this u bar as a linear combination of v1 bar, v2 bar, v3 bar. So we assume here u bar is equal to, take u bar is equal to alpha 1 u1 bar plus alpha 2 u2 bar plus alpha 3 u3 bar. Okay, and if we want to determine the value of alpha 1, alpha 2 and alpha 3, so here u bar is equal to what? 1 minus 2 5. Okay, if there exists such alpha 1, alpha 2, alpha 3, then we can say that u bar as a linear combination of here v1 bar, v2 bar, v3 bar, v1 bar, v2 bar, v3 bar. Then we can say that u bar is a linear combination of v1 bar, v2 bar, v3 bar. If there does not exist such alpha 1, alpha 2, alpha 3, then we can say that u bar is not a linear combination of v1 bar, v2 bar and v3 bar. So here consider alpha 1 1 1 1 plus alpha 2 1 2 3 plus alpha 3 2 minus 1 1. So now if we simplify this, we get 1 minus 2 5 is equal to alpha 1 plus alpha 2 plus 2 alpha 3, then alpha 1 plus 2 alpha 2 minus alpha 3, and alpha 1 plus 3 alpha 2 plus alpha 3. Okay, now if we equate the LHS and RHS, then we get here alpha 1 plus alpha 2 plus 2 alpha 3 is equal to 1, alpha 1 plus 2 alpha 2 minus alpha 3 is equal to minus 2, and alpha 1 plus 3 alpha 2 plus alpha 3 is equal to 5. Now this is a non-homogeneous system of linear equation. So we want to express this into a matrix form. So if we express this system into matrix form, we get 1 1 2 1 2 minus 1 1 3 1 into alpha 1 alpha 2 alpha 3 variable matrix and right hand side matrix 1 minus 2 5. So now next we want to form an augmented matrix. So augmented matrix is, so this is Ax is equal to b, this is Ax is equal to b. So this is the coefficient matrix, x is a variable matrix and b is right hand side constant. So the next step we want to form an augmented matrix. So augmented matrix AB is equal to 1 1 2 1 2 minus 1 1 3 1, and we add one more column b in A. Okay, 1 minus 2 5. So the next want to reduce this matrix to row echelon form. So now to reduce this matrix to row echelon form, we are going to use the row operation R2 is equal to R2 minus R1. That is, we are going to replace the row R2 by R2 minus R1 and R3 as R3 minus R1. So if you apply this row operation, we get 1 1 2 1, then 1 minus 1 0, 2 minus 1 is 1, minus 1 minus 2 it is minus 3, and minus 2 minus 1 it is again minus 3. So again 1 minus 1 0, then 3 minus 1 2, then 1 minus 2 it is equal to minus 1, then 5 minus 1, it is equal to 4. Now next we want this the first non-zero entry in second row is equal to 1. It is already 1. So by using that 1, we are going to convert this 2 into 0. For that we are going to use R3 is equal to R3 minus 2 times R2. If we use this row operation, we get 1 1 2 1, then 0 1 minus 3 minus 3, then 0 0 minus 1 plus 6, minus 1 plus 6, it is equal to 5, and 4 plus 6, it is equal to what, 10. Next, if you multiply the third row by 1 by 5 into R3, then we get a matrix as 1 1 2 1, 0 1 minus 3 minus 3, 0 0 1 2. Now this matrix is in row echelon form, and here the rank of AB is equal to rank of A, which is equal to 3, and which is equal to number of variables, and therefore the system has unique solution. So to find a solution, again we are going to write this matrix form to system form as alpha 1 plus alpha 2 plus 2 alpha 3 is equal to 1, alpha 2 minus 3 alpha 3 is equal to minus 3, and alpha 3 is equal to 2. So from this we get the value of alpha 3 is 2. If we replace this value in above equation, we get alpha 2 minus 6 is equal to minus 3, so alpha 2 is equal to 3. And finally, if we substitute these two values in the first equation, we get alpha 1 plus alpha 2 is 3 plus 2 alpha 3 is 4 is equal to 1. So 3 plus 4 7, 1 minus 7 is equal to 6, minus 6. So alpha 1 is equal to minus 6, and therefore we get here alpha 1 is equal to minus 6. So from this we can write, so from this we can say that this there exists alpha 1 alpha 2 alpha 3. Therefore we can write u bar is equal to alpha 1 v1 bar, so minus 6 v1 bar, alpha 2, so 3 times v2 bar, plus alpha 3 2 times v3 bar. So, and therefore we can express u bar as a linear combination of v1 bar, v2 bar and v3 bar. You can reduce this matrix to row echelon form by using maxima also, or you can solve this equation directly. What is this equation in maxima? For that, if you enter here alpha 1 alpha 2 instead of alpha 1 alpha 2, if you use here say lin solve, and instead of alpha 1 alpha 2, if you write here x1, what is first equation? It is x1 plus x2 plus 2x3 plus x2 plus 2 times x3 is equal to 1. Then the second equation is x1 plus 2x2 minus x3 is equal to minus 2. And next, x1 plus 3x2 plus x3 is equal to 5, and variables are x1, x2, x3. Okay, so variables are x1, x2, x3, and you can see here what is the value of x1. X1 is minus 6, x2 is 3, x3 is 2. So you can check the value of alpha 1 alpha 2. Alpha 1 is minus 6, alpha 2 is 3, 2. So minus 6 3 2, we obtain the same solution here by using maxima. It is minus 6 3 2. The next example number 2. Okay. Determine whether given set the given set span R cube. So S is equal to 1 1 1 1 1 or 2 2 2, sorry, 2 2 2, then next 0 0 3, and next 0 1 1 1. We want to check whether given set yes span R cube, that is we want to check whether LS is equal to R cube. So for that we select an arbitrary vector, say A B C, from vector space R cube, and if there exists a scalar alpha 1 alpha 2 alpha 3 in terms of ABC, then we can say that the given set yes span R cube. So consider alpha 1 times 2 2 2 plus alpha 2 times 0 0 3 plus alpha 3 times 0 1 1. Okay, now if we if we simplify this, then we get ABC is equal to 2 alpha 1 plus 0 alpha 2 plus 0 alpha 3. So it is only 2 alpha 1, then 2 alpha 1 plus 0 alpha 2 plus alpha 3, and the last 2 alpha 1 plus 3 alpha 2 plus alpha 3. So now if we equate the LHS and RHS, we get 2 alpha 1 is equal to A, then 2 alpha 1 plus alpha 3 is equal to B, and 2 alpha 1 plus 3 alpha 2 plus alpha 3 is equal to C. So here from the first equation we get the value of alpha 1 is equal to A by 2. If we substitute the value of alpha 1 in the second equation, then we get 2 times A by 2 plus alpha 3 is equal to B. So alpha 3 is equal to B minus A, and if we substitute alpha 3 and alpha 1 in the third equation, we get, so it is 2 alpha 1 is A by 2 plus 3 alpha 2 we want to determine, plus alpha 3 is B minus A is equal to C. So this A and plus A and minus A will get cancelled here, and 3 alpha 2 is equal to C. So C minus B. So alpha 2 is equal to C minus B divided by 3. So, and therefore the vector ABC is equal to, we can write vector ABC, arbitrary vector ABC is equal to alpha 1. So what is alpha 1 here? A by 2, the first vector 2 2 2 plus the alpha 2 is C minus B divided by 3 is equal to into 0 0 3 and last alpha 3 is B minus A into the third vector is 2 0 1 1, and therefore we can write every vector from R cube as a linear combination in the vector of 2 2 2 2 0 0 3 and 0 1 1, and therefore the given set span R cube, and therefore set yes, what is the answer here? Yes, set yes span R cube. Again, I don't know whether we can solve such a type of equation in Maxima or not. We are going to try first. Suppose say here lens solve. I am writing here the first equation as lens solve. The first equation say twice x1 is equal to A, twice x1 is equal to A. Then the second equation is twice x1 plus x3 is equal to B, twice x1 plus x3 is equal to B, and the third equation is twice x1 plus thrice x2, twice x1 plus thrice x2 plus x3 is equal to plus x3 is equal to c, and the variables given, the variables are say x1, x2, x3, and yes, we get the x1 is a by 2. Is it a correct a by 2? Yes. And x2 is b minus c divided by 3. Our is what? C minus b divided by 3, so it is same as b minus c divided by 3. And what is x3? B minus a. You can check here, s3 is what? That is alpha 3 is what? B minus a. So instead of alpha 1, alpha 2, alpha 3, we use x1, x2, x3, and we get a solution in terms of arbitrary constant a, b, c, and therefore given set S span R cube. Now the next question number say 3. Determine which of want to determine whether which of the following want to determine whether given set is linearly dependent or not. So S is given, S is equal to again same 2 2 2 0 0 3, and here 0 1 1, and we want to check whether determine whether set yes linearly dependent. Again say here as consider alpha 1 times 2 2 2 plus alpha 2 times 0 0 3 plus alpha 3 times 0 1 1 equal to 0 bar in R cube. So what is 0 bar in R cube? 0 0 0. So if we get all alpha 1, alpha 2, alpha 3 is equal to 0, then we can say that the given set is linearly independent. Any one of them is not equal to 0, then we can say that it is linearly dependent. So again, if we write this as a 2 alpha 1, okay, then the second equation is 2 alpha 1 plus alpha 3, and the third equation is 2 alpha 1 plus 3 alpha 2 plus alpha 3 is equal to 0 0 0. So this is equal to, if we equate the LHS and RHS, we get 2 alpha 1 is equal to 0, then 2 alpha 1 plus alpha 3 is equal to 0, and 2 alpha 1 plus 3 alpha 2 plus alpha 3 equal to 0. From this equation we get alpha 1 is equal to 0. Okay, from this if we substitute this value here, we get alpha 3 is equal to 0, and we substitute this 2 value here, we get alpha 2 is equal to 0, and therefore all alpha 1, alpha 2, alpha 3 equal to 0, and therefore the set S is linearly dependent, or in other words, not linearly independent, independent, in other words you can say that it is what set S is not linearly dependent. So the now next example, find the coordinate vector of W bar. The example number 1 2 3 4, example number 4, let W bar is equal to 1 1 1 1, and we set S is equal to V1 bar, which is equal to 2 minus 4, and V2 bar is equal to 3 8. Find the coordinate vector of W bar. Find coordinate vector of W bar relative to the basis yes, relative to the basis set basis yes, which is equal to what? V1 bar, V2 bar, so to the basis yes. So basis set yes, say here instead of set yes, basis set yes. So now they are already basis, V1 bar, V2 bar already basis. So we want to determine what is the coordinate vector of W bar relative to this basis. So coordinate vector is what? If we express this W bar as a linear combination of V1 bar, V2 bar, then the value we obtain, alpha 1, alpha 2, are the coordinate vector of W bar. So first of all we want to write W bar as alpha 1 V1 bar plus alpha 2 v2 bar. Then what is the coordinate vector here? W bar, we related to the basis yes is alpha 1 alpha 2. So we want to determine the value of alpha 1 and alpha 2. So W bar is what? W bar is equal to 1 1 and alpha 1, the first vector is 2 minus 4, the second vector alpha 2 3 8. So if we simplify this, we get 2 alpha 1 plus 3 alpha 2, okay, and minus 4 alpha 1 plus 8 alpha 2 is equal to 1 1. So now if we simplify this, we get 2 alpha 1, if we equate the LHS and RHS, is equal to 1, and minus 4 alpha 1 plus 8 alpha 2 is equal to 1. So now to solve this, multiply the first equation by 2. So it is equal to 4 alpha 1 plus 6 alpha 2 is equal to 2, and minus 4 alpha 1 plus 8 alpha 2 is equal to 1. So if we add these two equations, then this will get cancelled here, and 14 alpha 2 is equal to 3. So this implies alpha 2 is equal to 3 by 14, and if we substitute this value any one of these equation, then we get 2 alpha 1 plus 3 times alpha 2 is 3 by 14 equal to 1. So if we simplify this, we get 2 alpha 1 plus 9 by 14 is equal to 1. So 2 alpha 1 is equal to 1 minus 9 by 14. So this is equal to 14 minus 9 is equal to, so 2 alpha 1 is equal to 5 by 14. So this alpha 1 is equal to 5 by 28. So this is the value of alpha 1 and alpha 2. We are going to check whether it is correct or incorrect. So again we are going to use here Linsol. Okay, the first equation is twice x1 plus thrice x2, twice x1 plus thrice x2 is equal to, plus thrice x2 is equal to 1, and the second equation is minus 4x1 minus 4x1 plus 8x2 x2 is equal to 1, and the variables are given x1 x2. So 5 by 28 and 3 by 14. So whether it is correct, 5 by 28 and 3 by 14, yes. And therefore coordinate vector of W bar relative to the basis yes, which is equal to alpha 1 alpha 2, which is equal to alpha 1 is 5 by 28 and alpha 2 is what? Alpha 2 is here 3 by 14. They are the coordinate vector. Now the next example number 5. Here the set R square is given on an operation defined as, say here, set V is equal to R square is given, and with operation, say with operation and plus and dot. Okay, now the vector addition and scalar multiplication is defined as, xy plus x dash y dash is equal to x plus x dash plus 2 and y plus y dash and kxy is equal to kx ky. Determine whether V is a vector space. V is a vector space or not. So here, if you consider the first condition, say C1 closureness, so x plus xy plus x dash y dash is equal to x plus x dash plus 2 and y plus y dash. So since these x y are, they are all real number, so x dash y dash is also real number, so this x plus x dash plus 2 y plus y dash is also real number, so it lie in R square. And C2 is defined as k is any scalar and xy is any vector, then kx ky is also lie in R square for any scalar k, where k is what, a real number, k is any scalar. So the first two condition is hold. For the second condition, we want to show here, take first vector a1, take u bar is equal to xy and v bar is equal to x dash y dash. Then u bar we want to show here, now u bar plus v bar is equal to xy plus x dash y dash, which is equal to x plus x dash plus 2 y plus y dash, and it is nothing but, okay, this is same as x dash plus x plus 2 and y dash plus y, so this is same as x dash y dash plus xy, and therefore which is same as v bar plus u bar. So the first condition is hold. Similarly, you can show here associative is also hold. Now we are going to check A2, you can check for homework, okay, associativity A3. Now suppose u bar plus 0 bar is equal to, okay, say u bar, we want to determine what is the value of 0 bar here. So u bar is given is what, x, what is u bar, xy, say u bar 0 bar plus is equal to xy. So what is the value of here 0 bar, and okay, so here if you apply, so here if we take say 0 bar is equal to, say 0 bar is equal to minus 2 0, then if we check here xy plus minus 2 0 under this operation, what is the operation here, x minus 2 plus 2 and y plus 0, so this is nothing but the xy, and which is equal to what, u bar. So the 0 bar is equal to minus 2 0 and which lie in R square, and therefore A3 is also hold. Now for A4 we want u bar plus minus u bar is equal to 0 bar. So here that is xy, say u bar is equal to AB is equal to again say minus 2 0. That is, if we simplify this, we get x plus a plus 2. The operation is given is what, xy plus x dash y dash is x plus x dash plus 2 y plus y dash, and y plus b is equal to minus 2 0. So here we get x plus a plus 2 is equal to minus 2 and y plus b is equal to 0. From this we get y is equal to minus b, and what is value of a here, x is equal to what, x is equal to say 2 minus 2, that is minus 4 minus a. So x is equal to minus 4 minus a, then minus u bar is equal to xy, so that is minus ab, which is equal to, sorry, we want the value of a and b in terms of x and y, not x and y in terms of a and b. So we get here, sorry, b is equal to minus y, and a is equal to minus 4 minus x. So a is equal to minus 4 minus x, and b is equal to minus y. So if we take any vector xy, say any vector xy, and if we add into that vector minus 4 minus x minus y, then what is the output here, x minus 4 minus x plus 2 minus y minus y, not minus 4, but here we get x minus x will get cancelled. Here it is minus 2 0, but we want 0 0. Sorry, here what is 0 bar here? 0 bar is equal to, yes, we want it is equal to 0 bar, correct. So here we get minus 2 0, and which is equal to what? 0 bar. And therefore what is minus u bar here? If u bar is equal to xy, then minus u bar is equal to minus 4 minus x and minus y, which also lie in r square, and therefore a4 is also whole. Now we are going to check whether m1 is whole. So for m1, say m1, take u bar is equal to xy and v bar is equal to x dash y dash, then u bar plus v bar is equal to x plus x dash plus 2 and y plus y dash, and alpha u bar plus v bar is equal to alpha time x plus x dash plus 2 y plus y dash. Okay, so if you simplify this, we get alpha x plus alpha x dash. What is given? Scalar multiplication. The scalar multiplication is given is what? Kxy is equal to kx ky. So want to multiply this alpha to h entry, so it is 2 alpha and alpha y plus alpha y dash. Now consider alpha u bar plus alpha v bar. So if you write alpha u bar plus alpha v bar, it is alpha times xy plus alpha times x dash y dash. So this is equal to alpha x alpha y and plus alpha x dash alpha y dash. Now for plus, we get alpha x plus alpha x dash plus 2 and alpha y plus alpha y dash. Okay, now here you can check, this is what? Here 2 alpha, we obtain here 2 alpha, but here we get only 2. So alpha u bar plus v bar is not equal to alpha u bar plus alpha v bar, and therefore it is not a vector space. It is not a vector space.